my talk, Duck Hunt, retro gaming, gaming meets cutting edge innovation in this quacking good tech adventure. Just a minor warning, some of the code I wrote, some of the text I wrote, and some of the images are. I think nowadays that's not normal. Who am I? My name's Dale. I'm now known as the Duck Builder after last year's DevConf. I'm a father, husband, software developer, hardware hacker, maker, retro computer enthusiast. I consider myself an old fart. I've been paid to write software for over 24 years now. I'm currently a tech lead and senior software developer at a company called DealX. In my free time, I take things apart, and occasionally they go back together. I am probably now best known for ducks and as the builder of Miss Duckworth, the AI-powered talking duck. And I'm a regular speaker at B-Sides Cape Town, a security conference, as well now, I guess, at DevConf. I always describe myself as a jack of all trades, serial skill collector, and high-functioning hoarder. You can find out all the social links and all the rest on my website, which is just xor.co.za. Just a quick note, the company I work for is hiring people. So if you can write C#, SQL, you can do something in a front end, you vaguely know what Doc is, maybe you've used it in production, you know some of those cloud things, and you want to work somewhere that's cool and allows you to come do these kind of things and does full remote, reach out on social media or somewhere, and we can chat. No guarantees, but like, yeah. Okay, so this is how it goes. Long, long ago. When I say long, long ago, I mean really long, long ago. When MTV was a music channel, when mullets were popular, and when mustaches were big. Home gaming was very, very different. Who remembers that? So that's the first gaming console I ever owned, the Golden China. If you had money, you had one of these. It's the same machine, but it came in gray. In searching for images, I found out that this in 1989 cost 199 Rand. Now, if you translate that, it actually makes PlayStation, the new PlayStation, look cheap. So all these machines are what they call Family clones, which is a clone of the Nintendo Family Computer, which in itself is the Japanese version of the Nintendo Entertainment System, which is a bit odd because Nintendo are Japanese. But anyway, that's how it works. This is just some of the games we used to play on this thing. Contra, Mario Brothers, and all those kind of things. I'm sure if you grew up in the 80s or early 90s, you played these. And even if you didn't, you've probably stumbled across at least one of these games at some point. But that's not why we're here. We're here for this game. Now, I'm not about to tell you that this game was amazing. It wasn't. But it was cool because it did something that no other game did. It allowed you to interact with it using a gun and not the controller. So this is just some of the basic gameplay. And if you keep watching, you'll see a duck flies up. Bang. Pretty cool, hey? Okay, so the magic of this was these things. They're called the NES Zapper, or a light gun. And this is what made the game so cool, was you weren't sitting with a controller anymore, you were using one of these things. And as a little kid, I always was curious how it worked. I knew controllers worked because you push buttons, but I couldn't work out this thing. It was weird. It was different. And then life got hold of me and I forgot about it. Until one day, the slow-mo channel on YouTube did a slow-mo video of this. And things started to click. So here's how the light gun works. If you look at that, up here, on the right-hand side is a lens. And what it does is it focuses the light from the TV, it pushes through. Behind that metal box, there is a light sensor, and then there's some electronics that feeds it into the game console. And that's it. It's very, very simple, very cheap, very easy to make. But how did it work? So watch this. This is that same gameplay clip, and I'm just going to play it again. Did you see it? Let's play it slower. Now watch. And bang. That's how it works. So the way it worked was you had your duck, and when you pulled the trigger, the screen goes black. And that is a calibration step. Now the gun in the console knows what black looks like. And now it's looking for something not black, which is the square where the duck was. And as long as all that timing is correct, you scored a shot. And that's all it does. It's just looking for light at the right place at the right time, which is why it doesn't work on modern LCD screens, because the timing is all out of whack. So my plan was, let's rebuild this. Let's make it again. Let's make it better. Because how hard could it be to make a simple game? So here's my original plan. Create a modern Duck Hunt game. Build a custom gun that used AI to find targets. 3D printed epic looking housing for it. Make it awesome. So here's the shopping list: AI camera, Raspberry Pi, LCD screen, some batteries, LEDs, motors, and a whole 3D printed gun. This thing was going to be epic. Step one in all of these things I have learned is I need to file a budget request, so I went and did that. Yeah, no. So now we have to pivot. I have no money for this talk, but it's okay. We'll get it done. So these are the actual constraints. First one is 6 weeks. The entire talk plus the game needed to be done in 6 weeks while still being a husband, a father, and doing that full-time job thing. So best case, 60 to 80 hours, best case. Next problem, no budget. My wife made it very, very clear that I was not allowed to spend money. After last year's duck, I am not allowed to do anything. So I have a plan, but I think I can get away with 200 Rand if I don't drink any water on the plane. And probably coffee as well. So, next thing, I want to make it multiplayer. The original Duck Hunt could only be played as a single player. Because it's drawing squares on the screen, things get complicated when you're trying to do it any other way. But that's boring, and especially nowadays. I want more players. And then finally, no additional hardware. You shouldn't require anything fancy that you don't already have. And then no duck killing, because I kind of like ducks. How hard can it be? Okay, so the first problem to solve is, where are you pointing? Now, there's lots of ways to do this. I could do the NES Zapper mode, but again, it only allows one person. There's motion capture using optical tracking and cameras and fancy things you stick on stuff and all that kind of thing. But it's expensive and complicated and requires cameras. And the thought of bringing more stuff to wasn't going to work. The other option is Xbox Connect. If you ever saw those were those fancy little camera things you hooked up to your Xbox, and they had a depth camera essentially, so they could find an object and you could kind of figure out where your hands were and all this kind of thing. It works for one person. It kind of works for two. It falls apart after that. Next option, the Wii Remote. The Wii Remote is probably one of the fanciest controllers around, and it does have a way to determine if you're pointing it at the screen and where you're pointing. The problem is, I'd have to buy lots of Wii remotes. I do have a few, but I'd have to buy more, and that's more money, and I don't have money. Finally, Lighthouse. If you haven't heard of Lighthouse, Lighthouse was a tracking system originally developed by Valve. It was used on the HTC Vive, and it basically involves putting little boxes in the corner of your room, and those allow you to track an object. It works very, very well, and it has been open sourced, and so it's available, but again, requires money. But I had a different idea. What about using a camera you point at the target? But now I need to know where I'm pointing the camera. And this is how I do it. So this is a pick and place machine. This is how your PCB boards inside your electronics get built. This machine runs past and puts all the parts in the right place at the right time, and it does it very, very fast. And the magic to this are these little things. They're called fiducial markers. You put them on your PCB board, and in your layout software, you say, this one's in this corner, this one's here, and all the other parts are so far from those markers. On the actual machine, it's got a camera, and it finds those and then works out how far from that it needs to move to put down the one part it's busy putting down. Now, a few years ago, those were commonplace. There was this very brief period before all the VR hype where there was this thing called AR. I'm sure you remember those few weeks that those were popular. Now, AR took over the world for like literally 3 weeks, where everyone was popping up dinosaurs in rooms and things like that if you had the right cell phone. And you can tell how long ago it was by the cell phone in the corner there. But the way it works is you put down this QR-looking code, and it can determine which way you've turned the code. And it can determine if it's facing you or facing up. So now, what happens if I reverse all this? So here's my plan. There is a computer screen, and you'll see in the 4 corners, I've got these QR-looking things. And it turns out I can find them. So now let's assume this 640 by 480 image, you're aiming at the mushroom. That's in the center of the screen. So now what will happen is my code runs and it finds the markers. So you'll see 0, 1, 2, and 3, and there's a 17 up there that is a false positive. But now what happens is I found the 4 markers and I know where they are because I put them on the screen. So now what you can do is, because I know where they are and I know which way they're orientated, I can do this. So if you know where they are, you know where their corners are, and you can crop the screen, and you can do all the stuff to straighten the image. So even if you're looking at it from the side, sort of where I'm standing, it will still work. So to do this, you have to build a translation matrix. I'm bad at math. I didn't bother. There's a cool thing called OpenCV. It did it all for me. And basically what it does is it takes this warped image and maps it back. And I map it back to a 1920 by 1080p image. And what you end up with is that. And as you can see, it looks like a normal image. And that's just being recropped, trimmed, straightened, and everything else. And then what I do is I say, okay, in the original image, at the center of the screen, 320 by 240, if I take that location and I translate it through the same translation matrix, I get that little blue dot, which is still on the mushroom. So now I know that you were aiming at the mushroom, assuming you can keep all 4 markers in your screen. So now I know where you're looking with the camera. Now I need some hardware. Okay, sorry. So the first thing is this is all done using OpenCV, which is a very cool library. Now I need some hardware. So I need something perhaps handheld, with a screen, with computing capabilities built in, with a battery, with the connectivity. Do you see where I'm going here? Yeah. So something you already have as well would be nice. The plan is that. What about those cell phone things? They've got all that. Okay, so now we're getting somewhere. So here is the master plan for the new Duck Hunt. I'll have a game client, which will be the target field you're shooting at, and that runs on the computer. And it connects to a server that does all the background work. And then on my phone, I'll run a client that will act as the gun. So here's what all the server's done and built with. The server is a Python application. It's done with fast API for the HTTP and the WebSockets. I originally didn't use fast API. I just went to Google's Gemini and said, create me a project. And it went and picked something and built something for me. And it used a 9-year-old WebSockets library a WebSockets library that hadn't been touched for 9 years. And when I queried why, it said, because it was popular. Probably 9 years ago, but still. I decided to use SQLite for the database. This was a bad idea, but I did it anyway because I needed something that I could easily query and read from. I do write to it occasionally, which causes problems, but who cares? It's fine. It will be okay. And then finally, I need to it handles the hit detection. So I give it an XY, and it says you hit something or you didn't. And all of this runs over WebSockets, which makes it much, much simpler. And it means all the game clients and everything else can just be web pages. And finally, it's got a few HTTP endpoints that allow you to load the map and the scores and things like that that are more static information. And all of this also serves all the all the HTML files and the JavaScript and everything else. Next up, I went on a side quest because why not? So off I went on my little side quest and I built my own CI/CD pipeline. Now, the main reason I did this was because all these things require HTTPS, which is very, very annoying. It's fine if you're on your one machine because everything's localhost and then it doesn't care about certificates. But the minute you have a cell phone and a desktop app running on something else and a server component and they're not running on the same machine, they will still need certificates because it's got to be all secured. And I wasn't going to be bothered with doing all the certificates and everything else. So I just pushed it up all in the cloud and made it someone else's problem. The whole pipeline is pretty simple. It uses GitHub Actions to build everything inside of containers. I've got Godot, which I'm using for the game side. So that's all handled also in containers. All the stuff then gets pushed through and it builds a final container, which then ships over to DigitalOcean. The reason I'm using DigitalOcean is I have a budget and I happen to have some credits there, so it makes it slightly cheaper, which means my wife will be happy. So that's the game client. That's what the game looks like when you're playing. As you can see in each corner, I have those markers. There's the high scores and there's a few messages coming from the game. And the object of the game is pretty simple. You just got to shoot the little things. So here's how it works. What you see on the big screen, all of that is written in Godot 4.4. If you've never heard of Godot, it's a game engine. It's the same as Unity or Unreal Engine. It's quite a nice game engine. It's open source. It's freely available. It's got a bit of a learning curve. It's no worse or better than Unreal or anything else. Pick whatever you like. Pick whatever you want to use. It doesn't really matter. I'm doing this for fun. All it does is it displays the game state on the screen from the server that it pulls. It's all written in HTML. Well, it's published to HTML. So one of the cool things about Godot is you can tell it to push to PC, Mac, Linux, Android, iOS, and to an HTML project. And what it does is it compiles the whole of Godot and all the bits and pieces and all your code into WebAssembly and pushes it out. It is a 50 meg WebAssembly file, but we're used to that nowadays. The awesome explosions you'll hopefully see later if this all works is just the normal CPU particles 2D, which is the way that you can render particles. The reason I can't use the fancy GPU ones is because it's an HTML project and those aren't available. The problem with the CPU ones is if lots of things explode, my laptop gets a little bit warm because it's trying to render all of these things all on the CPU while still loading Chrome with a 50 meg JavaScript file. So you must know this is fun. The tracking markers, as I said, are in the corners. And one of my failures is it's limited to a 1080p screen. The only reason is I couldn't figure out scaling in Godot. One day I'll get that working. And this is the gun client. This runs on my phone. And as you can see, I'm busy looking at the screen. In the middle, there's a little target. And whatever I shoot there and I tap the screen, it will shoot it. In the top right is the score. In the top left is the full screen button. And in the top left bottom corner is the gun rocket. Originally, I had grand plans of having multiple weapons and all these kind of things and different kind of explosions and all this kind of stuff. But I had 6 weeks. And unfortunately, I did need to sleep a little bit. The gun client is pretty simple. It's written in JavaScript and HTML. I'm not a JavaScript developer. It superimposes the crosshairs over the image. It uses WebAssembly's OpenCV, or the OpenCV port to WebAssembly to find all the markers in the image. It calculates the XY coordinates, and then it sends those coordinates to the server via WebSockets. But there's a catch. There was a previous version of this game client. Now, when I say previous version, this was about 7-8 days ago, previous version. It was also written in Godot 4.4. It also was a WebAssembly export. It used WebAssembly to OpenCV to find everything. It calculated the XY coordinates and everything else. It worked okay. And that got replaced. And here's the reason why. So it turned out, despite what all the AI tools, if Godot targets WebAssembly, you can't use a camera inside of Godot. It's unfortunately one of those limitations. All the AI tools said it could be done, but it can't be. But it's okay. I found a workaround. So the way this works is the camera grabs an image, then it converts that image in JavaScript to base 64. Then it takes the base 64 image and passes that through to Godot. Godot then decodes the base 64 image and then converts that image and pushes it onto the screen. And does that for every single frame as you move your camera. Now you start seeing why things get bad. Oh, and by the way, this doesn't take into account the fact that there's also all the checking and the vision stuff and everything else also happening somewhere in that loop. There was another problem. Everything online, or AI tools all say it's possible for Godot to work. Godot targeting WebAssembly will work with OpenCV, but it doesn't. They all tell you to use this thing called GDE extensions, but GDE extensions only work for native code. They don't work when you're trying to target WebAssembly stuff. So again, I had to write JavaScript code that would do all the OpenCV stuff and then wire all of that stuff back into my massive loop using this JavaScript bridge. Now, all of this is doable. It works fine. It's just that you only get like 4 frames a second on a good day. Now, this is the important part. What do the critics say about this? Well, my son said it was almost as much fun as Minecraft. My daughter, the explosions could be bigger, and some random stranger on the internet said it looks pretty. So I think this is a huge success. But in all truth, it was. That's my son and I playing this for about 30 minutes, 40 minutes, just before I came to DevConf. My game works, and my son actually sat with me and played it. Now, here's all the cool tools. I bought this list because these are the things that I stumbled across while building this. Godot, like I say, it might work for you. Give it a try. Gemini kind of speaks Godot, which is quite nice. Not well, but kind of. If you squint really hard at the text it generates, it kind of makes sense. OpenCV is fantastic. I've used it multiple times, and I discovered this WebAssembly port of it, which is very, very nice because you can then run it in the browser. Blender, I didn't quite use it. I used it for stuff you'll never see, but Blender is a 3D graphics program, but it integrates very well with Godot. So you can make 3D assets and just push a button and they appear in Godot and you can use them. That Sprite is a sprite pixel editor, which some of the graphics were done in, others I cheated. And it's also available free on GitHub. Now, I'm going to chance the demo gods because we're going to try and do this live using my cell phone for the internet. So let's see if this works. So in the middle is my game. I have to put in a name. The game pops up. And rotate. Now, can we turn up the lights a bit and see if this, I'm just going to try playing here and see if this works. Come on. So the game idea is basically you shoot these things and, okay, so what I'm going to do is I'm going to move on to the second step of this talk. So what we're going to do is, because it doesn't work for me, it doesn't mean it won't work for all of you. So this is where I get very, very brave or very, very stupid, and I'm going to regret this. So if you would like, you can take out your phone and just go to that website, xor.co.za/game, and just tap the gun one. Don't tap the other one because then you'll have the board. So once you've done that, so a couple of you can do that. And then you can aim. I'll put the screen back up and you can aim and you can play. In theory, you should all be able to shoot. All you have to do is keep the 4 markers in your screen. Like I said, it doesn't always work properly. I haven't sacrificed enough ducks to the demo gods. Speaking of which, anyone want ducks? Cool. I promise. Whoa, sorry. I knew that was going to happen eventually. Okay, so if some of you loaded the game there, then I'll switch this quickly across. And let's see. Yeah. Too many screens. There we go. Okay. Go wild, try and play. Let's see if it works. So you should be able to shoot things. Just keep tapping. Like I say, you got to keep the 4 little corners in the screen. There we go. I knew I built something that worked. So there we go. Wow. You guys are way better than Joburg. Either that or I fixed the bug that caused the back end to crash. So there we go. I know the game's not tons of fun, but here's the cool part. You guys can all play. And if Joburg was happening at the same time, they could join the same game. Because the back end is all web posted. So you just open up that page. So it means that where you are doesn't affect your gaming. And you can game in 2 places or 3 places with as many people as you like, as long as you have a screen, the perfect lighting, and a cell phone. So eventually I'll turn this into something more fun, hopefully, if I ever find any time. I have a lot of sleep to catch up on. But yeah, someone is doing very, very well there. Very well. I have questions. Have you been practicing, or do you have the... Just by the way, it's all unsecured. Yeah, there's a map endpoint that gives you the location of all the mushrooms and everything else. So you could pipe those back into the WebSockets and make an auto-playing thing. I don't think anyone here knew about this, except maybe Ross. But yeah, okay. Let me carry on with my slides. Yeah, if I can find my mouse cursor. Cool. So, please vote for me. Only 4s or 5s. If you got anything lower, come speak to me afterwards. Don't give me feedback. I need to impress my wife so that she'll let me do these things in future. You guys can win prizes, so it's probably a good idea to vote. I'm pretty sure that one now goes to Cape Town and not Joburg. We caught it this just a few minutes before. It's not a proper talk if you're not editing slides 5 minutes before the talk. Otherwise, you can catch me on LinkedIn. I'm the person who's been posting ducks on social media. If you're on LinkedIn, Blue Sky, Mastodon, that X thing, and or GitHub, like, yeah, I'm the one who posts all the ducks. Thanks very much for coming to my talk.